As you can see, I've already shown all my working out for this question. I'll just talk you through it. So for proving the identity in part A, I've started on the left-hand side because there's a lot for me to do there. I've got the tan squareds that I can swap, and then I've got the fraction that I can tidy up, and hopefully I'll end up with the sec 2x. So the tan squared, I've rewritten that as sine squared over cos squared, because most of the time I prefer to work with sine and coses. So I've turned the tan squared on the top into sine squared over cos squared, and I've turned the tan squared on the bottom into sine squared over cos squared. Now, that leaves me with the awkward situation where I've got these two fractions inside another fraction, which I don't like. So I'm going to tidy that up. The way I'm going to tidy that up is I'm going to multiply the top and the bottom of this fraction by cos squared. The reason why I've chosen to do that is because I've noticed that if I times the top by cos squared, that's going to cancel that out. Obviously, if I times the top by cos squared, I have to do the same to the bottom, which also has the nice convenience, it's going to cancel that out. So let's go through each step, because the 1 will also be multiplied by the cos squared, of course, which gives me cos squared. Then, like I say, the sine squared over cos squared times cos squared. The cos squareds will cancel out and just give me with the sine squared. Moving to the denominator, the 1 times the cos squared is cos squared. The sine squared over cos squared times cos squared will just leave me with the sine squared because the cos squareds have cancelled out. Right, at this stage I notice that I've got the cos squared plus sine squared, which we know is just 1. And then on the denominator, we've got this cos squared minus sine squared, which I recognise as being one of the cos double angles. Remember, the cos double angles are cos squared minus sine squared, or 2 cos squared minus 1, or 1 minus 2 sine squared. So this on the denominator is identical to cos 2x. And I know that 1 over cos is sec. So that completes part A of the question. Moving to part B, it says hence. So I know I'm going to be using the result from part A. And I notice that this here is exactly the same as what I had in part A. So it can be replaced with the sec 2x. I've still got the plus 2 equals 0. So that's where that line there comes from. Next, I've subtracted the 2 from both sides to get that sec 2x is equal to minus 2. And now I know that sec is 1 over cos. So I'm going to do the reciprocal to both sides. The reciprocal of sec is cos. The reciprocal of minus 2 is minus 1/2. I've done cos inverse of minus 1/2 and found that my first solution is 2 pi over 3. I've then drawn the graph, and I've drawn the graph twice as big as you might expect. You might have expected me to only draw the graph up to 2 pi, but I've drawn it all the way up to 4 pi. And the reason why I've done that is because in a minute I know I'm going to be dividing everything by 2, so I need twice as many solutions. So let's look at the graph in a bit more detail. Here's the minus 1/2 on the y-axis. Here's my first solution, which was 2 pi over 3. So my second solution is going to be 2 pi minus 2 pi over 3, which is the 4 pi over 3. The next solution is going to be 2 pi plus 2 pi over 3, which is 8 pi over 3. And my final solution is going to be 4 pi minus 2 pi over 3, which is 10 pi over 3. Then I'm just going to divide everything through by 2, and that gives me my final solution.